Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode of Quarantine Chai with my machine learning heroes, CTDS.Show. In this episode, I interview MarieAnne from Facebook AI Research. She's a research engineer at Fair Lab in Paris. She has recently put out a joint work. The paper is titled Unsupervised Translation of Programming Languages. And if you're not aware of it, it was completely mind-blowing to go through it and understand what it's doing. I think the title gives it away. But we dive into her research and her journey into the field. We dissect the work behind the paper and her research. MarieAnne shares her perspective on how they were able to make this work and quite literally translate code from one language to another. So if you're excited to know more about it, here's the conversation. Please enjoy the show. I'm really excited to be talking to MarieAnne, who's on the call with me. MarieAnne, thank you so much for joining me on the podcast.
Thank you.
So I know that you put out a very interesting work recently. We'll talk about that. But before that, I want to talk about your journey. I had read that you worked on something that's similar to what you're working on today. But during your master's, you had worked on detecting pattern structure. Can you tell us more about the same and how did it connect the dots for you? How did you get interested in machine learning?
Yeah, so when I did this master thesis, it was about finding the pattern in finding the regularities into patterns. So what a pattern for me is what you see, for instance, in clauses or on curtains. So it's very small elements that are put together to do a drawing, for instance. And when you see it, you don't see it like random elements, but you do see actually regularities. Yeah. So, but it's very hard to define what a regularity is, because it's not just like, for instance, aligned elements or circle. It could be like a bit more. Something that you see, but that you can't really explain why you see some irregularities. So my master thesis was about finding automatically these regularities and express them. So basically, I had to to express all this. I build a graph on these elements, and this graph represents all the orientation, for instance, the size of the elements, the distance between the elements, and I had to compute some algorithm to find all the matching subgraphs into this pattern. And this matching subgraph show me, for instance, if you have, I don't know, I will give you an example. I think it will be clearer. If you have, for instance, 4 elements that are put to draw a square, so you have 4 elements that are at the corner of the square. You have this little square, and you can have in your old pattern another square, but it's just a bigger square. And your eye are going to see that these 8 points are drawing 2 squares. And the aim of my algorithm was to find that the graph that represent this square are into the whole graph. You have actually 2 subgraphs that describe the same shape, And these graphs are not isomorphic, but are what we call matching graphs. So it's not exactly the same, but they are kind of the same because the size, for instance, is different. So yeah, and my whole algorithm was about to find some similar graphs, subgraphs in my whole graph to find some repetitions in the whole pattern.
Interesting.
So it was an algorithm that it was not deep learning. It was more like unsupervised learning because I at the time when I did my master thesis there was no pattern dataset. So I just have to do something that was totally unsupervised. So yeah, it was about finding matching some graphs.
Did your interest for unsupervised learning broadly originate from there, or was there another
No, it
dot?
was more like I had a teacher in my. It was computer graphics and image classes, and one of my professor worked at this time on pattern, and he did some papers about patterns because he worked with, I don't remember the company, but he works with all the the editing image editing software companies. So he was working with them. And at that time, there were no tools to edit pattern in a very smart way. So basically,
They're
if you
still
have a
not.
pattern,
They're
yeah,
still not there.
if you have a pattern in your draw and you want to I don't know, move one element and you want that all the pattern follow your edit to adapt. Actually, there were no tool to do it. So basically, you have to move all the elements by hand. It was like very time consuming. So he worked with this company to make it smarter. So he suggested the project, and I was very interested in it. So yeah, I started like that. It was not because I want to do unsupervised, more because I found the final goal interesting.
Okay. I'd also love to know what made you pick up. You followed, if I may, a traditional path into research. Why did you pick research as a career path over industry?
Actually, because so when I did my master thesis, it was in computer graphics and image processing. So at this time, I studied a bit of deep learning for computer vision. But I didn't follow many classes on machine learning. So I didn't follow any classes on NLP, for instance, or in more general machine learning. So at the end of my master thesis, I really wanted to learn more in machine learning because I had a lot of friends that were studying machine learning, and I found it like very interesting. So I hesitating between doing some, because I thought that if I was going to do some research, it was the perfect way to learn many things on that field. So I was hesitating between doing some research in that field or doing another master in machine learning. So I just applied to Facebook and Google to do research there, and I I succeed my application. So I was like, okay, I think this is a perfect way to improve my skills in machine learning. And so yeah, I enter the research there, and I'm very happy there. So I just want to keep going as long as I can.
That's awesome. Today,
Yeah.
like you mentioned, you're at Facebook AI Research Fair. My researcher friends would know it's called Fair.
Yeah.
Can you tell us more about the lab? I think you're at the Paris lab and you work out of the Paris lab on non-pandemic days. And for people who are not aware, what is Facebook AI Research?
So in Facebook, you have a lab that is called FAIR, so Facebook AI Research. The aim of this lab is to do public research. So everything we do there is to open source our papers, to open source the code if we can, open source the datasets. So it's really to share the research that we do with everyone in the field. And after that, if we have some research that can be used in production, then we give all the research we did and the code to other teams. So it's not fair that is going to put anything in production. It's really other teams in Facebook. And you have, I don't remember how many, but I think 6 or 7 labs in Facebook. So you have, the biggest one is the one in Paris.
Okay.
Then you have yeah. Then you have a very big one in MPK, so Menlo Park in California, and one in New York. So I think these three labs are the main labs, and then you have others in Tel Aviv, for instance, in London. And we are, yes, collaborating between all the labs. And in each lab, something that is maybe a bit different from academic research is that you have research, so you have scientists, so the one that have PhD, and then you have research engineers, so like me. And every project is built with one scientist and engineers help scientists to work and give some support to build like bigger projects. And so yeah, you have collaboration between scientist and engineer all the time.
Okay. To me, and at least to some people, these words research and engineer are so different. Can you tell us what does a day in your life on non-pandemic days look like? What tasks do you work on?
Yes, so basically I code. So, but not all the time. So my days are during my days. So I code if I have to build a new feature in my code base for my project. I run some experiments. I think this is the biggest part of my work, depending on the project, because when you are an engineer, you can be assigned to projects that are very like engineer projects. So you, for instance, you have engineers that work only on PyTorch, so you don't, for this project, you don't have any experiments. You just have to implement the code base. But for a project like the one we just did, Transcoder, you have a lot of experiments to run. So I run the experiments, then I check the log, I test my model to see if it goes well. Then you, as a research engineer and first author of this paper, you have to write the whole paper. Then in the company, for instance, for this project, I built a demo, so internal demo for my project. I did a blog post that is going to be available soon. And yes, and the other part is you are in meeting and you are like talking about your research and what you are going to do, and you exchange ideas with other people in your team, with the scientist of your project. So for us, it was Guillaume Lampe. And you have also meeting with your manager that is checking that everything is going well, if you need anything. And yeah, basically is that.
So the manager in your case is also sort of an academic advisor. If you were to do a PhD, if I can relate to that.
Yeah. So if you are an engineer, your manager is not part of your project. Is someone that is outside of your project. So it's not an academic supervisor, but more a care people supervisor. Like is just seeing that everything is going well, but is not working on your project. But if you are a PhD like postdoc, for instance, then your manager is also your supervisor.
Thank you for
So
the
for
plug.
engineer, yeah, and PhD, it's a bit different.
Okay. Thank you for the plug. I've interviewed PS Talk earlier, so audience, if you would like to check out another interview with another researcher from FAIR, please find that in the show notes. I was really blown away. I'm sure the complete machine learning community would agree by your work. And
Thank
for
you
the
very
audience,
much.
if they'd like to look up the paper, it'll be there in the show notes. But if you'd like to Google it, it's called Unsupervised Translation of Programming Languages. Can you tell us more about the overview of the problem to help us appreciate it better?
Yeah, so the problem is that usually when you do translation, so machine translation for natural languages, you have access to parallel data. So you have a data set that is, for instance, for English, French. You have one sentence in English that is translated in French. So you can learn on this parallel data. But for programming languages, you don't have access to this parallel data sets. You only have monolingual data sets, so all the code that is available on GitHub, for instance. So you have to build in order to have a system that is able to translate between programming languages, you have to build a system that is trained in an unsupervised way. And this is actually the very challenging part of the project.
So
So
it's
to address this problem, we have used before we did this project, many advanced machine translation show that you can train with some algorithm that we use in our project, unsupervised algorithm on for natural languages. It worked pretty well. So we were thinking that maybe if we adapt a bit the tokenizer to use programming languages, we can use this method on programming languages. And we tried and it worked. So
why is this a difficult problem? Because it's already been demonstrated that it works okay for general languages. What's the challenge? I'm trying to understand and appreciate the problem better when you're trying to work with programming languages.
So the first part was that you had to build new tokenizers, because the tokenizer to pre-process the data, you have to have tokenizer, and the one that you use for natural languages are not the one that you can use in programming languages, because there are some tokens that you want to separate, or on the other way that you don't want to separate. So we had to build these new tokenizers. And apart from that, I think that all the methods that you can use in natural languages, you can use it for programming languages. Maybe the only thing that for us was a bit like a question whether or not it is going to work is that how to explain it, but when you have a sentence in French, you will always have this sentence in English
Yes.
that have exactly the same meaning. But for programming languages, you have some programming languages that can express something in one line that you can't express in another programming languages. So we thought that the learning could be like more difficult for this task than for natural languages. So we didn't know when we started if it was going to work the same way that it worked for natural languages.
So
It's
I
I
know
think it's a more difficult task. Yeah.
I know you're a PyTorch user. Theoretically speaking, can this be used to port over my TensorFlow code to PyTorch? Can this
Yeah,
approach
I
be
think so.
extended?
Yeah. I think if you train like on code that use TensorFlow versus code that use PyTorch, we didn't try that, but it could be like a low-hanging fruit follow-up for this project. I think it could be like very interesting. Yeah.
Okay. But coming back to the problem, can you share a bit more about the training details? And I believe you've used a single shared model for all of the language translation. Why do you think it works effectively, even though how these programming languages are structured? For example, you just mentioned it, but Java is very verbose, Python is less verbose, but it still works effectively. What does your intuition say about that?
So the first thing that we did to check whether or not it was going to work is the pre-training. So the first step of our method is the pre-training. So you pre-train one model on so for us it was C++, Python, and Java in a math language model with a math language model loss. And the aim of that is to, with one model, to obtain what we call cross-lingual representations. So what we mean by cross-lingual representation is that we want the token that have the same meaning. So for instance, int, integer, and for Python you don't have any int, but the same token in all the languages to be embedded on the same representation, which means that the model learns the correspondence actually between the languages. So this is the very first step, though. For that, you need to have just one model. And this is possible because you have some anchor points in all the programming languages. So you have common tokens in all these between all these programming languages. And thanks to these, I think, common tokens, your model is able to align the representations. And the first step was to pre-train and to check whether or not the embedding of the token that have the same meaning are effectively mapped to the same representation. So we check that, and we also check that the model is able to learn a language model. So we just to our model to test it, we give, for instance, the beginning of a function, and we checked that the model was able to generate something that is syntactically correct for the programming languages, and it was the case. So we discovered that the model is able to have cross-lingual representation and to learn language models. So yeah, I think if you have that, then the main part of the work is done. And after that, we train the translation part. But this is, I think, the major component, one of the major components.
Interesting. How do you evaluate this work? Do you take the programs, run it through a compiler and check if it works, or how do you benchmark how effective is it?
Yes, so before a work, people used to use the same evaluation method as the one used in natural languages. So for natural languages, to evaluate your translation, you just check so you have a ground truth, the reference. And so you have in your test dataset, you have a source, then you have the reference, and you check that the generated sentence is close in terms of tokens to your reference. But for programming language, and you compute a blue score, for instance. But for programming languages, we thought that it doesn't have a lot of meaning, as you can just change one token in your generation compared to the reference, and it can change the whole program. So for us, for instance, if you have, I don't know, an inferior instead of a superior sign, then your program is totally different. But in terms of tokens, it will have a very good score. So for us, it was not a very good metric. So we decided to implement some unit tests that check that the generated, so we just test on functions because it's easier to evaluate.
Right.
And we check that the generated functions output the same output for a given set of inputs compared to the reference. So basically, we run this unit test. So we check that the code compile with this, and that the code gives the same output, so as a good running time.
You're taken a different approach for masking and back translation. Do you think it was also central to making this approach work?
Yeah. Because the first thing is the pre-training to have cross-lingual representations. But if you just limit to that, your model won't be able to do anything because it has never been pre-trained to generate something. So the second step of our algorithm is to do what we call denosing autoencoding. So basically, you take a function, you mask, as you said, some tokens, and you train your model to generate, so to reconstruct this masked source function. So doing this, your model learn to generate something based on, so you encode your source, then you give the encoding to the decoder, and then your model generates the reconstruct reconstruct function. And so doing this, your model learns to embed something and condition on this embedding to generate. So this is crucial to do translation, because if your model never learns to generate something, it won't be able to do it at test time. And then because you have a very good cross-lingual representation, your model has been able to learn, so to embed, for instance, a C++ mask sequence, then to generate the C++ reconstructed sequence or function. And if you have very good cross-lingual representation, if you give a function in Python, then the embedding is close to the C++ representation, and then you can do at test time to give a Python function and to generate the C++ reconstruction. So basically, if you stop there, your model is able to translate, because you have very good cross-lingual representation. You learn the model the model have learned to generate. So basically, if you stop there, you can translate. But if you check the translation, they are not very good because you have never done translation at training time. So back translation is here to improve the quality of the translations. So all the components are needed.
Okay.
Yeah.
What would be one low-hanging fruit if someone was to take this approach and extend it to another problem? What's the future easiest task that someone could extend it to?
Okay, so I think to train on other languages would be programming languages would be very good, because I receive many emails and questions to, okay, I am working with SAS and R, for instance, in my statistical problem. I want to go from one to another, but it's time consuming to reprogram all the things. So this could be very useful. For instance, MATLAB versus Python, I think could be very useful too, because you have many professors, for instance, at a university that used to use MATLAB in their tutorial, and they want to and it would be today more useful to do it in Python, but it's just too time consuming to port all the tutorials. So it would be very useful to have this MATLAB Python system, TensorFlow versus PyTorch as well. Then we have other projects that we want to test, but we don't want to tell more about that yet, because we don't know if we are going to work on this or to let other people do it. So we have ideas, but for now we just want to keep them with us.
We'll try to get MarieAnne again on the show to know more about it. How can one effectively collect data sets for these approaches, and how did you collect the data set for your research?
So Google BigQuery is a public service that allow you to download. You just have to pay something, but it's not that much, and you can download data sets. And Google BigQuery has put GitHub data sets. So basically, I just download the data from there, and then I implement the tokenizers, the detokenizer, and all these functions that are needed to process the data, and I process the whole thing. So basically, if someone wants to, we are almost done with the open sourcing of our code.
Okay.
And if someone wants to work on other programming languages, the only thing it's not a little thing, but the thing that that the person will have to do is to download from GitHub, from Google BigQuery, the programming languages he wants, and then to implement the tokenizer and detokenizer. And it can run, I implemented a pipeline that process the whole thing. So you just have to implement these tokenizers, and then the preprocessing can be done with the code that we are open sourcing.
So every bad line of code that bad engineers commit to GitHub is actually stopping AI from becoming effective and taking away our jobs.
No. You will still need some engineers for sure.
Taking a step back, I'd also like to talk a bit about PyTorch, your thoughts on the framework, and if you can also give a teaser of any upcoming features that might be on the release radar from Facebook.
Actually, I don't know this. I'm sorry. So I work with PyTorch, but I'm not aware of what are the upcoming features that is going to be open source. So
Okay.
I won't. I can't say anything about that. I'm sorry.
Okay. This is usually a final question, and I like to really ask my research heroes about how do you think a MOOC educated person, since not everyone has the privilege of taking a master's or a bachelor's even in the field, how can a MOOC educated person cultivate a research mindset? What should they do being an independent researcher, maybe with limited resources, single graphic cards?
Yeah, so I think that a MOOC, an only MOOC educated person can do some research very effectively, because I don't think you need to go to a very prestigious university to learn what you need to do some research in AI. But I think that one thing that is very important in research is to have some chat, to discuss with people, to exchange. And for me, but it's only my opinion, but I don't think that if you stay alone, you will be able to do some research, because I think one major component that you have to get is to have some how to say, but if is to have some very experienced researcher that are going to give you what they learned during, like, I don't know, 10 years or 5 years, and
Some level
all
of
this
guidance.
yeah, and all this experience that you get from all these years. Then if you have this, you can ask some question, you can try to see if there is something that you can improve in their work, and then take this research to propose another method or something. But I think, yes, to have the guidance of a good researcher, I think it's very, very important.
Okay.
Because as far as I'm concerned, when I joined Facebook, I had all my education background, and then I improved my skills just because I was with very like very good scientists, and they learned me a lot of things. They have the intuition, and I think the intuition is very hard to get if you stay alone, because they have the intuition because they have like done many projects before, and the intuition they get it from all this work. So yeah, I think it's really useful to be surrounded by a research environment.
To your point, I also think Facebook research or even other research labs don't have a strict requirement that you absolutely need a PhD or a master's in CS or otherwise. So from the audience, I think even anyone can apply if they are interested in contributing to research.
Yeah, but I'm not sure because I this is the first place where I work, so I'm not sure for more. For instance, in France, it's in area, but all the academic lab, I'm not sure if you need to do, for instance, an internship or something to I don't know if you need that to apply for internship. But you can also go to conference and just chat with to attend all the presentation, and then go you go to the poster session, for instance, and just chat with the scientists and meet them. And I think people are very like open, and if you meet someone at a conference, then if you have a question, you can just send an email and do a chat with this person, and maybe it's sufficient.
If I was able to get you on the show, so people like you are always kind to help enough the help the community. I think the barriers are being lowered, and to your point, all conferences are mostly online these days. So it's easier to approach great people like you if you're attending a conference.
I think so. I think you can just yeah, because all the researchers present a poster. You have the poster session, and at the poster session, it's really free. Like, you can just go to the poster that the research poster that you're interested to in, and then you can ask your question. And I think everyone is very open to answer. And yeah,
Absolutely.
yeah, I think
Bef-
it's easy.
Before we end the call, what would be the best platforms to connect with you or follow your work for the audience?
I think so for the open sourcing, I think we're going to post something on Twitter to say that we are open sourcing the code. And then on the archive version of a paper, we give all the mailing address of me, Guillaume, and Baptiste, and you can just send emails. And actually, I receive, like, I don't know, 10, 10, 10 or 20 emails of people saying I want to work on your field, and I would like to add the code and the dataset. When will it be available? And I just take all these emails and put it on a note. And once it is open source, I will just send an email to all of this person to say it's open source, you can use it.
That's amazing. I also think for your profile, you're also active on Twitter and any other social media profiles that you'd like to mention, any platforms where you're active.
I No, I think there is only Twitter. We're going to put, but we are just going to put a blog post on the Facebook AI website to summarize all of our work. But apart from that, I think no, there is no. And yeah, you can send an email, but there is no other channel that I use.
Okay, amazing. Thank you so much for joining me on the podcast and for
Yeah,
your
with
amazing
pleasure. Thank you.
contribution.
Thank you very much.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.